Okay, welcome to the series on permutation and combination. So this is the second lecture, and if you have not watched the first lecture, please go back and complete the first lecture of multiplication principle, and then you can start with this video. Okay, we'll cover a good amount of questions and good conceptual questions in this lecture. Okay, so here we have example 4.21 filling posts. MUN committee has 10 representatives from Asia, 8 from Europe and 7 from Africa. If a representative is eligible for maximum of one post, in how many ways can a secretary general, deputy secretary general and a president to be chosen for the committee if there are no further restrictions? Okay, so what do we have here? From Asia, there are a total of 10 representatives. From Europe, there are 8 representatives, and for Africa we are having 7 representatives. So in total we will be having is 25 people. Okay, now we need to select a secretary general, we need to select a DSG, and we need to select a president, and there are no restrictions. So let's start with the first part. So I want to select a secretary general, I want to select a deputy secretary general, and I want to select a president. Okay, so can I say when I want to select a secretary general, I am having total of 25 choices, right? And once one of them is appointed to be a secretary general, how many people will be left? Only 24 people will be left. So this becomes 24 choices for DSG and 23 choices for president. Okay, so this answer comes out to be 13,800 ways. Okay, second part, what does it say? That the secretary general must be from Asia, the deputy secretary general must be from Europe, and the president must be from Africa. Okay, so now for secretary general, for deputy secretary general, and for president, if secretary general is from Asia, how many choices do we have? We have 10 people. For DSG, it should be from Europe, we have 8 people, and for president it's from Africa, so we have only 7 people. So for this case we are having 560 ways. Okay, next case, it says that they must each be from different countries. Okay, they should be from different countries. Okay, so let's select countries first. So for SG, for secretary general, for DSG, and for president, for secretary general there are 3 different continents. It's Asia, Europe and Africa. So for the secretary general, let's say we are having 3 choices for continents. For DSG we will be having 2 choices, and for president we will be left with only 1 choice. So total number of choices are 6 for selecting a continent. Okay, now once we have selected the continent, can I say for example this will be having combinations like this. It will be an Africa, Europe, or it could be Africa, Europe and Asia, or it could be Europe, Asia and Africa. So there will be 6 different choices like this, and out of those 6 different choices we'll select one of them. Okay, so let's say I have selected this example. I have selected the example where secretary general is from Asia, DSG is from Europe, and president is from Africa. So in that case, can I say I will be having 10 choices times 8 choices times 7 choices, and this is irrespective of whatever the selection we take, it is always going to be 10 times 8 times 7. So this becomes 560. So can I simply say that first we will have to select, so now can I say that first we'll have to select the continent and then we'll have to select the people. So the answer becomes 560 times 6, which is equals to 3360 ways. Okay, so first we are selecting the continent and then we are selecting the people based on that continent. So 6 choices for selecting the continent and 560 choices after selecting the continent for different positions. Okay, next case, what do we have? They must not all be from the same continent. They should not all of them be from the same continent. Okay, let's say, let's use complementary counting here. Okay, so let's say, let's find all from Asia. So if all of them are from Asia, can I say for Secretary General I will be having 10 choices, for Deputy Secretary General I will be having 9 choices, and for President again I will be having is 8 choices. So in total I have 720 choices. Let's say all from Europe. Okay, and let's say all of them from Africa as well. So all from Europe and all from Africa. Okay, so here we had 10 times 9 times 8. So here Europe there are how many people? Europe there are 8 people. So 8 for the Secretary General, 7 for the DSG and 6 for the President. And here we will have 7 for Secretary, 6 for DSG and 5 for President. So now we will have the multiplication is 720. This will become 336 and this will become 210. So in total what we have is 1266. Okay, now I have the count for all of this people. When I have selected all people from Asia, when I have selected all people from Europe, and when I have selected all of the people from Africa. Okay, now can I use complementary counting to find my answer? What I will do is I will simply subtract from total number of ways. I will subtract all the ways where the people are from same continent. So my answer will be total ways minus the ways where all are from same continent. So how many total ways were there? 13,800. So 13,800 ways minus what are the ways where all of the people are from the same continent? It will be 1266 ways. So 13,800 minus 1266 becomes 12,534 number of ways. Okay, so here we have used complementary counting to find the answer. Okay, and this is the last part. This is also interesting. Exactly 2 of them must be from the same continent. So exactly 2 should be from the same continent. Okay, again we can use our complementary counting. So what should be our answer? Can I say our answer will be total ways minus where all are from the same continent. All from same continent, and we'll also subtract where all are from different continent. So all from different continent. So we have the answer for all being from same continent, we have the answer for all being from different continent, and we have the value for total number of ways. So total number of ways are what? 13,800 minus all from same continent. What was the answer? 1266. So minus 1266 minus all from different continents. So what was the answer? Where all were from different continents? 3,360 ways. So minus 3,360 ways. So the answer comes out to be 9,174 ways. Okay, so the final answer is 9,174 ways. Okay, so this was a long question, but yeah, this is a very important question to understand. Okay, uh, a restaurant offers 3 desserts and exactly twice as many appetizers as main course. A dinner consists of an appetizer, a main course, and a dessert. What is the least number of main courses that a restaurant should offer so that a customer could have a different dinner each night in the year of 2003? Okay. Okay. So in 2003 is not a leap year. So 2003 will be having 365 days, which means there will be 365 nights. Okay, next thing. We do not have information on appetizers and main courses. So let's assume that number of main courses are X. So number of main course is equals to X. Okay. So how many different types of dinners will be possible? So when I select desserts, I need to select a dessert, I need to select appetizer, and I need to select main courses. Okay, so for dessert, how many choices do I have? I have 3 choices for dessert. For appetizer, how many choices? Twice as many as main course, so 2x. And for main course, how many choices do I have? X. So this becomes how much? 6x square. Okay, now what do we need to find? What is the least number of main courses that a restaurant should offer so that a customer could have a different dinner each night? So can I simply say that the condition we are looking for here is 6x square should be greater than 365. Okay, so the smallest value of x, we will get the answer as 8. So the smallest value of x is going to be 8. So we need at least 8 main courses so that for 365 nights we'll have a different dinner on each night. Okay, solving this, it's simply x square is greater than 365 by 6, and you can solve it further. Okay, this is interesting. I'm going to a party wearing a total of 2 rings on the 5 appendages. So appendages is similar to fingers of my right hand, 4 fingers and 1 thumb with no restriction. I can wear more than 1 ring on a finger. We can consider it as finger. Also, the order of the rings matters in how many ways can I wear 2 rings. Okay, so I have 5 fingers, 4 fingers and 1 thumb. So let's say 1, 2, 3, 4 and 5. This is thumb and this is finger 1, finger 2, finger 3, finger 4. Okay, let's say I'm having 2 different rings. Okay, I'm having one white ring and I'm having one green ring. Okay, so if I select first ring, which is white ring, how many choices do I have? Either I can put my white ring over here, 2, 3, 4 or 5, right? So for the first ring, how many choices did I get? I got 5 choices for the first ring. Okay, what about second ring? Let's find out. Second ring. So for second ring, can I say either I can put it over here? Let's say out of this 5 choices, I selected one of them. I selected it on the first finger. So for second ring, can I say I can have different choices 1, 2, 3, 4, 5. Okay, these are the 5 different choices. Or can I say that this can be interchanged, right? White can be on the top and green can be after white, right? So can I say in total I will be having is 6 choices, 1, 2, 3, 4, 5 and 6. So 5 times 6 is going to be 30 ways. Okay, so it's not going to be 5 times 5, it is going to be 5 times 6, which makes the answer as 30 ways. Okay, next it's a follow-up question for the same thing. Let me take this. Okay, now in this case what do we have? We are having 3 rings. One is white, one is green, and let's say one is red. Okay, so let's take this case. Let's take this case where I have two rings like this. Okay, let's say I'm wearing a white ring over here and green ring over somewhere over here. Okay, so when it comes to the red ring, how many choices do we have? We have one choice, two choice, three choice, as we can see, fourth choice over here, and fifth choice over here, sixth over here, and seventh over here, right? So can I say in total I will be having is 7 choices. So if I just copy this, and for the third ring now I am having is 7 choices. So 6 times 7, so this makes it as 210. So the total number of ways are 210 ways. Okay, let's move to the next question. Find the number of 2-digit numbers with no restriction. We do not want any restrictions for this. Okay, let's move to the next question. Find the number of 2-digit numbers with no restriction. Okay, so 2-digit numbers. So we are having tens digit and we are having ones digit. So digits start from 0 to 1 to then 0 to 9. Okay, but I cannot select 0 as a tens digit, right? If I select 0 as a tens digit, it will make it as a single digit number. So for tens digit I only have 9 choices, 1 to 9, but when it comes to ones digit I have 10 choices. So the total 2-digit number without any restriction I will be getting is 9 tens are 90 numbers. Okay, next, find the number of 2-digit numbers where both the digits are odd. So both the digits should be odd. So tens and we have ones. So how many choices for the tens part? I have 5 choices. Either it can be 1, 3, 5, 7 or 9. And second digit should also be odd. So 5 times 5. So total I will get is 25 numbers. Okay, next, how many 2-digit numbers have tens digit exactly 2 more than the units digit? So tens digit should be exactly 2 more than the units digit. So if I am having 1, so the tens digit should be 3. Okay, next, what is the next possible combination? 4 and it should be 2, 5, 3, 6, 4, then 7, 5, 8, 6, 9, 7. So how many combinations we get? We'll get total of 1, 2, 3, 4, 5, 6 and 7 combinations. And one more which we missed is going to be 2 and 0, because 0 this is also valid. So total combinations we'll get is 8 combinations. Okay, last question for this session. A palindrome is a whole number that reads the same forward and backward. So for example, a palindrome is A, B, A. If you read it from here or if you read it from here, it will be same. Or A, B, B, A. Reading it from right to left or reading it from left to right, it will be same. Okay, a palindrome is a whole number that reads the same forwards and backwards. If one neglects the colon, certain times displayed on a digital watch are palindromes. Okay, that is correct. So for example, 101. So if we ignore the colon, it becomes 101 or 1221. So how many times during the 12-hour period there will be palindromes? So we need to find for a 12-hour period. Okay, so first thing, can I say that either there will be only two cases because maximum digits are 4, right? So either it is going to be, ABA, so for example 101, or it is going to be ABBA, which is 1221. Okay, so let's talk about ABA case. Now for ABA case, I am having this is units digit of hours, units digit for hours, then we are having tens digit for minutes, tens digit for minutes, and then we'll have units digit for minutes. Okay, now how many choices do I have for units digit of hours? Can I say it can be anything? It can start from 1 till 9. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm having total of 9 choices for units digit. Now if I have selected one of the digits as the starting point, can I say for the last point I will have no other choices than selecting whatever I have selected at the first? So if it is A, I have to put it as A. If it is 3 here, I have to put it 3. If it is 4, the last digit should also be 4, which means for the last digit I am not having any choice. Okay, now it comes to tens digit. So what are the possible tens digit? It can be either 0, 1, 2, 3, 4 or 5. We cannot have 6 because it's a there are only 60 minutes, so we can have from 0 till 5. So we'll have a total of 6 choices. So here in this case we got 54 ways. Okay, now let's consider the second case. Second case is where we have A, B, B, A. Okay, so along with the units digit we'll have tens digit of hours. So we'll have one more, which is tens digit for hours. Okay, now how many choices will be there? Can I say either it can be 1, 0 or 2? Either it can be 0, 0, either it can be 0, 0, either it can be 11 or it can be 12. Okay, or it can, even if it's 12, for the first digit either it can be 0 only or 1 only, 0 or 1. Okay, and we cannot take 0, because if it's 0 it will be considered, it has already been considered in this case, which means you are only one choices for the tens digit, so it is going to be 1. So for tens digit, if A is selected, there will be only one digit, one selection for this also. Okay, now coming to the units digit hours. So can I say either it can be 10 o'clock, 11 o'clock or 12 o'clock? So I have three choices, either it can be 0, 1 or 2. So if I am having three choices for the units digits hours, so tens digit, if this is already B, so this has to be, so there are only one choice for this. So 3 times 1 will become 3. So in total we'll have is 3 plus 54 is equals to 57 ways. So the final answer is 57 ways. Okay, this was it for this video, and let's meet in the next video. Thank you for watching. If you are having any doubts, you can please put your comments and I will reply to all of them. Thank you for watching.